This is the 3D model that will be the particle. It is very simple. I am just using a quad with a length of 40 centimeters. I am just going to subdivide it and then adjust the vertices. Now I just push the polygon in the middle a little bit. Now I simply go to this option to be able to visualize the normals. And now I modify them inside mesh normals point to target. Then I modify the normals to point upwards and apply the rotation transformation. Now it's ready. This is the script that I use to control the shader. It has variables like width, height, and to control the wind like angle, speed and force, a volume variable. And these lines are not working, and finally some variables for the spatial shader. Now I pass the variables to the shader. The amount is the amount of GPU particles. As you can see in the documentation of GPU particles. Everything else is the shader variables, and bottom part is the variables for the spatial shader. Now, the shader takes the variables from the outside. I use an include file with some functions, and this is the remap function. And the most important part is this rotation function that creates a rotation matrix in 3 dimensions. I'm going to move this random function to the include file. And now I use the process function because all the animation is done inside the particle shader. Other people use the spatial shader to do the rotations, but I like this way. First I will create a variable to store the transformation of the particle and then assign it. I have to do it this way because, unlike other shader types, particle shader kept the data from the previous frame. Then I get strange effects such as infinite rotation of the grass on the y-axis. Next I get the square root of the particles and multiply it by the ratio between the width and height. So I get the columns and rows. Now, because shader programming is in parallel, I can iterate over the index variable that contains the reference of each particle. I have to use other functions like mod to apply a wrapper to get the columns, then divide the index by the columns to get the rows. Now I get custom coordinates, dividing each index by the columns and rows. Here I use the remap function to get values different from 0, for example from 0.3 to 1.0 in this case. Now I take the position of the particle emitter and calculate the upper left corner. Then I define the space between the particles in x and y. I assign the position of the particles. And finally, I hide the particles depending on the mask, moving them to a very far position on the y-axis. I get the wind direction using the rotation function and the wind angle from the parameters. Then I rotate the texture of the noise using the coordinates of the wind direction. I get a random rotation in the y-axis. This is static. And in the x and z-axis, I use a sine wave plus the random value to get the random movement. And finally, I apply the rotation to the transform. I can't remember what this line of code does, so I will leave it as it is. I apply the basis to the transform, and I'm going to transform some information to the spatial shader. This is the spatial shader, and I use again the include file and the remap function. I get the colors from the parameters and make an interpolation using a curve. I get the noise value from the particle shader. Here is the curve to adjust the color, and I can adjust it from the GDiscrete parameters, as you can see. I make an interpolation with the curve. And here I am applying the noise texture, which comes from the particle shader. Finally, I adjust the normals so that they always face the front view. And this is the end.